guys, Miss Collins here. Today we're going to be going over the study guide for the Unit 3 test. At the beginning of the study guide, there's some kind of helpful tips and tricks. These are things that you should definitely study in order to prepare for the test. The first tip is about adding and subtracting decimals. We'll see this later on in the study guide. It instructs us to line up the decimals and fill in the places with zeros, and then to drop down the decimal right into the answer. It then goes on to tell us about multiplying decimals. It says that here, when we multiply, we do not line up the decimals. You line up the digits to the right and multiple like normal, ignoring the decimals. You then count the places in the problem and move the decimal the same amount of places into the answer. When we divide decimals, if there is a decimal on the side, the divisor, then move the decimal to the right to make a whole number a divisor. Move the decimal in the house, the dividend, the same number of places to the right. The decimal on the roof is the quotient. Percent means 100 per 100 for every 100 or out of 100. Box plots. Create a box and whisker plot by finding the median, and then the median of the first half and the median of the second half. You start with the minimum and maximum. If I were you, I would definitely put these into flashcards or maybe do some highlighting to study these helpful tips and tricks located at the beginning of your study guide. Let's go over the first questions given to us. A. 30% of 50 is what number? Already referring to our helpful tips and tricks. I know that percent means per 100 or out of 100. So I know that I'm going to use the fraction 30 over 100 for 30%. And I want to find 30% of 50. So my original problem's going to look like this. I want to see how many times I can get this into this. But when I look at that, I know that it's impossible to put 100 into 50. Because of this, I know I need to reduce 30 out of 100 into an easier number. What I'm going to reduce it to, just to make it easier on myself, I'm going to take 10 out of it, the top and the bottom, and I'm going to turn this into 3/10. I now am going to try and figure out how I can turn 3/10 into a denominator of 50. This is a lot easier than it would have been with 30 over 100. I see the 10 here, and I know that I would be able to go into 50 5 times. We know that whatever we do to our denominator, we must go ahead and equally do to our numerator. So I'll also multiply it by 5. This will give me 15 over 50, which would be my answer. We will then go ahead and do the next problem together as well. Here, we're looking for 65% of 80. You're going to do the same thing where we know 65 would go under 100, over 100. Then we're looking for 80. And it's just the same thought process where you're going to be finding a smaller number that will go into it. Then you go ahead and solve across for 52. Now let's explain how we found A. How did we find 30% of 50? Let's look. First, we set up our fractions. Which were 30 over 100 and question mark over 50. We then reduced to 3/10 and solved for 15 over 50, which was our answer. Next question. Kieran took his friends to dinner. The total cost was $38.75. He gave the cashier $40 even. The cashier incorrectly gave him $3.37 in change. How much change should he have received? Again, our helpful tips and tricks at the beginning are helpful in solving this problem. This is going to be a subtraction problem involving decimals. We have 40 even dollars that we are going to lay out first. Next, we are going to take our $38.75 and subtract it from that. Okay, so you just go ahead and you subtract. And you end up getting $1.25. That should have been the amount of change that Kieran received. We will now do more problems involving decimals. We have addition, subtraction, multiplication, and division. This first one is another addition problem. We're taking 4.7, and remember, when we add them, we do line up the decimals. When doing this, we might have to fill some empty places with a 0. And we're doing 18, whole number 18, and 21.63. We're just going to very easily add this. Be a 3, I don't know what I'm doing. Alright, so just a pretty simple addition problem that would end up giving us 44. That would end up giving us what would look like 4,433. But then we remember that we just put our decimal where it belongs. We would get 44.33. or 44 33/100. We remember that though this is our correct exact answer, when we estimate, we're just rounding up. So we would round this up to 5, 18 would stay the same, and 22. And then you would just add across like that very easily. For B, this is a subtraction problem. I know that sometimes it kind of trips you guys up when you see that there is a equal bar on the beginning, but you can really just consider that to be the end because it is exactly the same. So you're just seeing what 9 minus 6.37 is. So like we said, we're going to line that up. And then we're just going to go ahead and subtract. Down, and lo and behold, you have your answer. C, this is a little bit different. We're going to be multiplying. When we multiply our decimals, just going to go ahead and set up our problem and multiply across. Alright, so when I multiplied this, I treated it as a regular multiplication problem. The thing that we do last is we count many decimal places there are and go over by that many. 1, 2. Which would give us our total of 9.52. Our final one for this part speaks about dividing decimals. When we divide decimals, we're going to go ahead and do our usual here. How many times like this? 55. Okay. Down. And you end up finding your answer that way. You're just setting it up the typical way, and then you're remembering that if there's a decimal on one side of the divisor, then you move the decimal over to the right to make it a whole number. You then move the decimal into the house, the same number of places to the right, and place the decimal on top of the roof, like we did. So that's all for that part. I definitely recommend studying that and maybe practicing a few examples if that's something that you do not have down yet. Still working with decimals, we have this here, and it's saying that we're estimating without really solving, just putting the decimals where it makes sense. So if you go and look at this problem here, it's 4.67 times 9.14. So you're kind of thinking, where would it make sense for the decimal to go? I think it would make sense for the decimal to go right here. Because when we multiply 5 times 9, for example, we're going to get 45. That was if I was rounding up here and rounding down here. This is the closest to 45. It wouldn't make any sense for it to be less, being 4, or more, being 426. We're going to use those same strategies with the rest. I multiplied 204 by 33. I know it's going to be over 1,000 for sure. So I'm going to have to put it, my dot, at least in the thousands place. For this final one here, I know that this is also going to be, by looking at it, over 1,000, due to the numbers that I have here. It's just what makes sense. For our final problem on this page, it says that Petra buys a bunch of bananas for her weekly snacks. Bananas cost $1.99 per pound. The bananas that she buys weigh 3.6 pounds. How much will Petra pay for her bunch of bananas before tax? When it says before tax, that means you do not have to worry about tax, so just, we're going to be working with these two numbers. So this, firstly, we need to decide what kind of problem we have here. When I see this word, per, this is an indicator of the multiplication problem. So we'll be multiplying with decimals. Remember, when we're using decimals in a multiplication problem, we just line the problem up regularly and deal with the multiplication later. So just multiply across. Alright, I got 7.16. Let's talk about why did I put my decimal in this area that I put it in. When we're multiplying decimals, we do not line up the decimals. You line up the digits to the right and multiply like normal. We then count the places after the decimal. So let's see if I counted correctly. 1, 2, 1. Seems about right to me. So the answer would be because this ends in money, $7.16. Alright guys, I'm going to go ahead and move on to my next page. And the next page looks like this. At the top, we see a box plot. Or a set of three box plots. And it's asking us a question. Describe what you know about the vehicle fuel economy in the last 3 years. So let's look at the last 3 years, assuming that it is 2012, even though it is not. So in the last 3 years, 1, 2, 3, when we look at it, we can see that it's relatively high compared to the years prior, but there is a slight drop in between 2010 and 2012, during 2011. When we go to our box plots, that helps us to answer B. Identify the box plot that best represents the same data. So we're looking for something that looks like this. An indicator here is where the data falls in the same places that it would fall on our bar graph here. On our bar graph, when we go to 22 per se, the upper quartile, quarter 3, will be above 22. There's only one set of information where the upper quartile, quartile 3, is above 22, matching this box plot. That would be the box plot A. Moving on to more box plot questions. Well, this is actually a decimal question, and there'll be more box plots to follow in just a moment. Armin paid $47.32 to fill his car's tank with gas. If the gas tank was empty and the cost of gas was $3.64 per gallon, how many gallons does the gas tank hold? Alright, so we're looking for how many gallons does this gas tank hold? He pays $47.32 all the way. And it costs $6.64 per gallon. So we're trying to see how many times $3.64 will go into $47.32. So that is going to be a division problem. Making our number model look as so. For our solution, we're going to use our basic model for division. And we're going to see how many times one goes into the other. Let's solve. Alright, I ended up getting 13. You can go ahead and check by seeing if $3.64 multiplied by 13 would equal $4.32. Here we are with dot and box plots once again. This is the final question on our study guide. The dot plot below shows the total attendance in millions rounded to the nearest 0.1 million at the 30 Major League Baseball stadiums